talk, of course, has a structure. We've been here for two days, 2.5 days, going on 3 days. What have we learned about modeling? What's the state of modeling in digital humanities? And I thought I would start by talking about the issue of the uses of modeling, and then go on to remarks connected to the form our models take, and then talk about issues of completeness. And of course, as you will have to be expecting after Wendell's beginning, the talk has another structure. We're going to start with remarks connected more or less tenuously to the Sapir-Whorf hypothesis and to Marx's theory of basis and superstructure. And then we will move to some issues related to the paradox of analysis. And we will end with a barrage, a farrago of quotations that I think, well, they start with Leibniz. Yeah, pretty much. In the second beginning of this talk, I take up Paul Caton's challenge to talk about the transcription of the carpet. Those of you who aren't physically here need to know, maybe you could pan the camera down and look at the carpet. The carpet is made of large and small rectangles with letters of the Latin alphabet on them. Various forms of the Latin alphabet. They're not all, strictly speaking, letters used in writing Latin. Some of them are used in writing other languages written with a Latin script. There's at least one E acute over there somewhere. This is actually a wonderful challenge, Paul, because the carpet illustrates a lot of the problems that we have. If you wanted to, you have to, of course, be patient and accept the idea that a transcription of a thing is, in some sense, a model of the thing. It's the transcription that faces these problems, but of course, the way we write the transcription faces these problems as well. The carpet is defiantly, ineluctably two-dimensional. And our usual representation of texts is based on language. All of our writing systems, essentially, in the world are being logographic and not ideographic. And language is ineluctably one-dimensional because I've only got one mouth. And conversation can be multidimensional, but our way of thinking about language essentially takes a lot from the fact that I can only pronounce one segment at a time, and therefore there is a sequence of segments that form my linguistic utterances. And this is two-dimensional. And if you wanted to transcribe them in a single order, if you just transcribe them in a single order, you'd lose all the information. Here's our first challenge. Which piece of information do we lose? Do we lose the fact that this U is next to a U, to a Y, to an O, to an O? Or do we lose the adjacency in this direction? You're all familiar with this kind of problem. You're all familiar with it either from the formatting of tables, where you must decide, or your markup language decides for you, whether you transcribe the table in row major form or column major form. Do you transcribe one row at a time so that the table is a series of rows and the rows are a series of cells, or do you transcribe one column at a time? It's 6 of one, half a dozen the other. Programming language implementers face the same problem and solve it in exactly the same way. And language specs that don't mind exposing things under the hood will tell you whether implementations are expected to be row major or column major, so that you can do dirty things with addresses. But if you do keep track of the two-dimensional coordinates, then you can at least record the information about adjacencies, even if they're not necessarily terribly convenient to get to. If you look more closely, you will see that, well, of course, this wasn't woven on a single loom. As far as I can tell, it's woven on a loom about 70 inches wide. And I'm pretty sure, at least I reached the conclusion, that in this part of the room, it's, which direction is this, east-west? It's east-west major. North-south, sorry. Local information is occasionally required. And over there is east-west major. And so you might want to respect that major orientation. It's a difficult choice because, of course, which way you transcribe it will have consequences. It will privilege one view over another, and it will make other views harder to get to. Even if you record the information, you can, of course, transcribe it twice, in which case you have more work if anyone updates it. It's also interesting because, in many cases, what you want to say is underdetermined. All right, this is a U, and its top is in that direction, and that's an S, and its top is in one of those directions. And yeah, I'm going to guess that the O's are probably mostly either in one direction or another, but you could imagine O's in which the number of possible orientations is either 4 or infinite. So there's a certain underdetermination, and it would be nice to be able to capture that. There's also, it's wonderful, the commentary on the carpet, on the plaque on the wall next to the door, illustrates a problem that has come up many times in the last couple of days. It contains factual statements, some of which some of us will want to distance ourselves from. Yes, the Latin alphabet is ancient and honorable, but it is, I would not be willing to put my name to a statement that it is the oldest writing system still in use with something like its current form and meaning. That's crazy talk. But it's there, so if you want to record that information too, you have to be able to record information that you don't believe. And you have to be willing to tolerate contradiction. And also the artist is concerned in the same way that many of us as humanists are concerned with the problem, with the fear of foreclosing possibilities. So there is a reassuring statement about the Latin alphabet. While it is not neutral, the Latin alphabet is a field that forms one of the linguistic traditions from which the research programs of the institutions here both arise. It has infinite possibilities because it has infinite possibilities for recombination. All of those themes we've heard before, and many of them you'll hear again in the next couple of minutes. The third beginning to the talk begins with a quotation from one of the grand old men of our field, Wilhelm Ott of University of Tübingen, who wrote a characterization of computing in the humanities, or digital humanities, many decades ago that still strikes me as being a useful description to come back to. He's speaking of electronic data processing and says, Ihr Einsatz ist überall dort möglich, wo Daten irgendwelcher Art, also auch Texte, nach eindeutig formulierbaren und vollständig formalisierbaren Regeln verarbeitet werden müssen. So, data processing can be applied everywhere where there is data of any kind, including texts, which must be processed according to unambiguously formulatable and completely formalizable rules. Remember those two properties. Unambiguously formulatable, completely formalizable. Now, notice he doesn't derive the necessity of formalization from the computer. He observes that it is a property of a great deal of humanistic research. As Stephen Ramsey said, and various people have echoed in various forms, data modeling of the kind that we've been talking about here is not new. In one form, one recognizable form or another, it's been a property of humanistic studies since humanistic studies got their name in the Renaissance. It's always been part of what we taught our students, at least up until the new criticism after the war. And as Ellie Milanaz pointed out the other day, you can read many of the results of humanist scholars and scholars through the centuries as being exactly the kinds of things we do, with the one proviso that quite often they have errors. They're not consistent in particular. And well, I think there are two ways to interpret that. One is to say, well, really, maybe they were doing something slightly different, and the other is to say, well, maybe they were human, and maybe there were mistakes. So what is different about what we're doing from what they were doing? At some essential level, nothing is my firm belief. It's a topic that keeps coming up, sometimes in disguised form, because it's tied to the question, is digital humanities a new discipline or not? And I'll go ahead and make my confession. No, it's not. The argument that it is essentially says, but digital humanities has to make things explicit, it has to clarify concepts, it has to see how things work. And I want to say, and philology and art history and history don't? What kind of teachers did you have if you don't think that it's part of the foundations of any scholarly work to be clear about your concepts and to check their implications? But there is one huge difference. I hardly need to tell any of you. We have computers today, and they didn't have them then. Now, for some of us, Wendell said this on the first day, that changes the way we approach our humanities disciplines. We're not in this room because we wanted to do digital humanities. We're in this room because we wanted to do humanistic work. And we do it digitally because we live when we live. How can you be serious about certain kinds of work and have a tool like the computer available to you and not want to apply it? Well, if you do apply it, of course, you have easier opportunities to discover the dirt and the inconsistency in your data than some of our forebears had. And our responsibilities are correspondingly higher. Now, in the fourth beginning of this talk, I thank the organizers for a small mercy. You did not begin the symposium with a panel discussion on the definition of the term modeling. Thank you. We would still be here. We are still here, but we wouldn't have covered anything else. But I will at least, I should make clear, because Fotis, for example, has several times pointed out that, you know, modeling, data modeling, not necessarily the same thing. The term data modeling has both broad and narrow connotations and so forth. So let me say at least briefly what I understand by the term and what this is partly descriptive, but mostly prescriptive. You see, I was trained as a philologist, not as an L linguist, and therefore I am perfectly happy being prescriptive. I do not have this tattoo, descriptivism only, on my arm the way people who went into the linguistics department got. So I'm happy to be prescriptive. One of the problems with defining modeling is, of course, that the word has a huge range of meaning. And it's a great example to use if you want to persuade people that Wittgenstein was right and you should just give up. But there do seem to be some things in common over a huge variety of uses of the word, and even more in common in the range of meanings that I think are applicable to us. The best definition I have seen is one quoted by Willard McCarty in his essay on modeling in the Blackwell Companion to the Digital Humanities of a few years ago. He quotes Marvin Minsky as saying, to an observer B, an object A star is a model of an object A if B can use A star to answer questions that interest him about B. About A. Which is beautiful. It has a wonderful advantage of covering every example I can think of. It has the disadvantage as a definition of the fact that it's not a definition, doesn't distinguish modeling from writing books. It doesn't distinguish a model of the German language from Fotis on the one hand, or Elke on the other hand, or even those of us who aren't native speakers but can answer a few questions about German on the other. So as a definition, it's no good at all. But it does capture something interesting and crucial about the relation of the model to the thing modeled, the sort of displacement, the lack of identity. And of course, it raises the question, well, why not answer your questions about A by looking at A? And the usual, or a common answer, is that A is hard to look at. A is complicated. So we use models to make our life simpler. Or because we're using a model to check some things before we commit ourselves. Maybe we are building A, and we build a model of A to say, well, what's this going to look like, kind of, sort of. So we build a model of a building, and we can say, oh no, we'd like that facade a little whiter. Can we lower the roof? Can we increase the fenestration? Can we do this or that or the other? And in this context, modeling is a means to an end. It is purely utilitarian. There are other reasons you might use models, and we'll come to those. There's an essay on modeling by Rosenbluth and Wiener, Norbert Wiener of MIT, that describes this utilitarian view. Sometimes the relation between a material model and the original system may be no more than a change of scale in space or time. At any proving ground, you can see what kind of consultant Wiener was. At any proving ground, experiments on shells will be carried out not with large, expensive, and unwieldy calibers, but with handy, cheaper, small calibers. Another example is the use of small animals instead of large animals for biological experiments. They're smaller, they're cheaper, they're quicker, they're easier to work with. So answer as many questions as you can with those models. Now, for uses of models of that kind, the incompleteness of the model makes no difference at all. The fact that a mouse is not really a good model for an elephant doesn't matter. They both have hearts. We can answer general questions about circulatory systems with the mouse as well as we can with the elephant. And one of the important uses of models in digital humanities is in the service of building things. You gotta build things. If you don't build systems, you don't produce tools that other people can use, what are we doing? One of the things that characterizes this field is that we produce tools, sometimes for ourselves, sometimes for others. And in building systems, we commit ourselves to things. Jan Christoph Meister's use of model, his explicit modeling of the kind of annotation he wanted to support struck me as being a perfect example of this kind of purely utilitarian model. And there are a lot of concerns that have been aired here that are of concern to us because we're interested in utilitarian models. The question of how to maintain models over time and how to track changes in models over time is really, I think, maybe not exclusively, but the most obvious reason to care about that is that we're using those models. We're not just admiring them. The tension that we see continuously between the needs of customization and standardization only exists because we're conscious that from a utilitarian point of view, standardization has virtues that customizations do not have for the community as a whole. And from a utilitarian point of view, customization has advantages for the individual project that standardization frequently doesn't have. So there's a trade-off of the good of the many versus the good of the few, and it's no wonder that the scale comes down so often on the side of customization, given that the people making the decision are the few, and it's their grant money that we're concerned with. Those of us who wish everybody would do it the same way so that we could reuse their data, will just remember that the shoe is sometimes on the other foot, and they wish you would do it another way so that they could reuse your data. And you may have a little more patience with those other people. The mapping between models seems often a utilitarian concern. But there's a second reason to care about modeling or to be interested in modeling. Let me cite another important figure in the history of our discipline, someone to whom we owe the TEI. Nancy Ide's first book was a book about Pascal. It was a textbook, Pascal for the Humanities. And in her foreword, she addresses the question, do humanists need to learn to program at all? And she says, no, humanists don't need to write their own programs. But experience with computer programming provides an understanding of fundamental computing concepts, familiarity with the principles of algorithmic thought, and a grasp of the ways in which information is stored, accessed, and manipulated. So yes, humanists need to learn how to program, not in order to write their own software, but to learn how to look at the materials within their discipline in new ways, and intelligently utilize and perhaps develop tools that help them do it. So I don't now remember who it was who mentioned information modeling as the modern equivalent of Greek and Latin. General intellectual training. It's right there in one of the important figures of our field. And it's true. If someone doesn't know anything about information modeling, I'm tempted to think they don't, there's part of their brain they haven't learned yet to exercise. So that hasn't been terribly well described here, although I guess it came up to a certain extent in the session on pedagogy. But there's a third use that we have for models, and that is to see the models as ends in themselves. The model is not something we build as a way to build something else. It is what we are working on. Alan's talk, Paul's talk are sort of pure examples of this. And again, here's a quotation, not from someone in digital humanities for a change, but perhaps the best formulation that I'm aware of this view of models as intellectual constructs in their own right is from a guy who works up north from here a little bit, Noam Chomsky, who wrote in the foreword to Syntactic Structures 55 years ago, precisely constructed models for linguistic structure can play an important role, both negative and positive, in the process of discovery itself. By pushing a precise but inadequate formulation to an unacceptable conclusion, we can often expose the exact source of this inadequacy and consequently gain a deeper understanding of the linguistic data. More positively, a formalized theory may automatically provide solutions for many problems other than those for which it was explicitly designed. So modeling can be more than just an epitome, a model of clear thinking. It can be the kind of thinking we are aiming at. It can be an end in itself. This connects with the characterization of XML, and before it SGML, that I owe to Lou Bernard, who always liked to begin our workshops by saying, markup is a way of making explicit our interpretation of a text. And that's what I want to say modeling is. Modeling is a way for us to make explicit our assumptions and beliefs, our premises, the premises for our work. Now, when models are an end in themselves, are a serious intellectual work product in and of themselves, apart from any systems they might help us build, then Wendell's second workflow becomes the natural way to do humanistic work. You want to work on the data, and you need to work on your understanding of the data. You capture your understanding of the data by refining the model. And that leads to what Julia described as schemas, as reflections of our convictions, rather than as recipes for things to do. Now, if you think of the model as a way of clarifying things we're interested in, then one obvious question is, well, what exactly do we need to model? Now, I was trained as a philologist, so my bias, my assumptions are heavily textual, and I realized as I was coming up here, you know, this is not a picture of things humanists are interested in. This is a picture of Roman Jakobson's model of text. And it's not really everything there exists in the world. But I don't have any other way to organize these remarks, so please bear with me. What are we modeling? Well, you can do worse at any moment of uncertainty about what to do with texts than think back on Roman Jakobson's essay on linguistics and poetry in 1960 Conference on Semiotics, where he puts up a model of communication. Where's that word again? First model of communication, you know, well, you have a message. It comes from a sender. A sender sends a message to a recipient. And then he observes this is hopelessly oversimple, and he ends up adding 3 more components to it. If you want to understand communication, it's not enough to have a sender, a message, and a recipient. They must be connected. So there must be contact. And they have to share a code. So there must be a code commanded by both sender and recipient, and typically the message is about something. So there is typically a referent. And there are functions of language devoted to all of those things. There is there is obviously declarative communication talking about the referent. There is expressive language talking about the state of the sender. There is conative language instructing the recipient to do something. There is meta language talking about the code. And there is phatic language establishing contact or checking on the contact. Things like, is this mic on? And of course, those of you who read this in your pro seminar in the first year of graduate school will remember the triumphant final function that Jakobson identifies as the poetic function, which focuses on the text itself. I always thought that was kind of hokey, but the model of constituents I continue to find helpful, and sure enough, we have models for many of those things. We have, and we've heard about many of them here today. We have no idea where those cards are. We have plenty of talking about the TEI and how you model the structure of the message itself. We heard indirectly through Paul about Digipal, which is a way of trying to encode some information about the carriers of the text and thus about the context. We have Kari Krause's frightening description of just what gets entailed when you really do care about the code and it's something for which that culture as a whole is not responsible, so you are responsible. So yes, we have the program and we have the runtime libraries that program requires, and we have the runtime libraries that those runtime libraries require. And you go down, and eventually you're going to need some chips or an emulator for those chips. And the boundaries are very, very slippery. And we have descriptions, Daniel Pitty's and Stefan Grodman's and Alexander Chmiel's about the demographic descriptions of people and places, which can be used to describe the sender and the recipient and the people mentioned, to the extent that we're talking about nonfiction texts. I don't think any one of those person databases talks about literary figures, do you? Anyone? Any records for literary? Yes? Oh, okay. So, thank you. He's got millions of fictive characters.
It's an equal opportunity description.
That's good. Now, this distinction between models of purely utilitarian character and models that are an end in themselves helps us, I think, recognize some of the discussions or some of the topics that have occasionally come up as inescapable, maybe not worth worrying about too much. I don't think I was the only person, I know I'm not the only person who thought, because at least one other person I heard say, oh my God, are we still talking about overlap on the first day? And whether that's a distressing proposition or not depends entirely on whether you're interested in modeling in a utilitarian sense, in which case you really would like to see some progress and you do not want to think that the community has spent 30 years discussing the same damn topic without noticeable movement in front. Although this is the way the First World War went, and you don't always have a choice about making progress. But if you think about modeling as a way to force ourselves to a better understanding, then it's not only natural for us to be talking about overlap, but essential. As Alan said the other day, there are some, for some things you're doing, if you're taking the modeling seriously, you don't go past that problem because there's nothing to go past it to. That is the problem that you are here to solve. If you don't get through it, what are you going to do? You go home, tail between your legs, say, I failed? There are some problems where it appears that the only way to get through the brick wall is to keep banging your head against the brick wall until either you find the soft place in the brick wall or your head gets harder. This is connected also to the question of whether we are modeling for ourselves or for others. And I think that humanists have utilitarian. I think that one reason parts of our situation seem new to us is that humanists didn't really used to have to worry about utilitarian modeling because we didn't build things. Computers have given us that possibility and that responsibility. And it also connects with the difference between a priori modeling and a posteriori modeling that was mentioned earlier today. Most of the time, a utilitarian model will be an a priori model. If it's not, you may have some workflow issues that you should be, and project planning issues that you should be dealing with. And I have the impression, I don't know for sure, but my layman's understanding is that the difference between utilitarian modeling and modeling as an end in itself may be easier to negotiate for engineers and physicists, in part because it's sort of discipline-based. The engineers do utilitarian modeling, The physicists are interested in natural law. Computers, however, changed the game there because of a phenomenon that was first noticed in our community by people involved with markup under the name tag abuse. Tag abuse, some of you will be striving to remember, is the use of HTML or XML elements in semantically inappropriate ways, typically motivated by an attempt to obtain a particular kind of processing. Classic example, in the early days of the web, if you wanted to get bold italic, the most reliable way to do it in some browsers was to tag the words as an H5. Now, they weren't headings, so there was a sense in which you were lying to the processor. But if the only processor you cared about was that browser, you were getting bold italic. It was only when you moved to a different processor and got different results, or when you applied a different process. You applied, for example, a processor that reads an HTML file and produces a list of headings, a table of contents, and you saw these phrases from the middle of your paragraphs showing up as headings. They're not really headings. Well, the program can't do anything about that. You lied. You lied. That's the cost you pay. It turns out that lying to the processor is not just ethically problematic, it's bad engineering. So in computing, in the creation of objects in this ethereal realm of computers, telling a utilitarian model and a model whose primary goal is to be true don't have nearly as much distinction between them as they used to. It now becomes primarily an issue of when we're willing to stop and when we're willing to cut corners. It is not an issue of difference of kind in the way that it may be between physics and engineering. The result is that with the advent of, well, at least with the advent of descriptive markup, and I think more generally, as we see in the discussion of modeling in other areas here, computers force us to think again and in new ways and with new urgency about the things of our discipline. And as Doug Knox pointed out, if there is something there that you don't have a name for, it's harder to think about it. It's almost impossible to ask questions about it. You may find you have to name things. You may have to reify them, not in the social science sense of making them impossible, making them beneath attention, but in the AI sense of making them into things that you can address and talk about and think about. And that's one of the reasons for modeling in general. One reason, why do we care about making our assumptions and fundamental beliefs explicit? So that we can look at them and say, well, actually, I don't like that one. Could we do without that one? Can I build a system that doesn't rely on that assumption? If you don't ever surface your assumptions, you're never going to be able to think about building that system, let alone build it. And you might want to build it because our assumptions turn out to have teeth. Now, Marx taught us years ago, and Sapir and Worf taught us, argued in a different way, that our thoughts are not always completely free. They are predetermined. They're not necessarily predestined, but they lean toward running in certain ways. They're influenced by things, and they're certainly influenced by our notations and by our assumptions. And when we reify those assumptions in the form of computer programs, we can really see what they were talking about. We can really see that a particular ideology has consequences. There is a sense in which doing digital humanities, doing humanities with computers, is playing humanities for keeps, because you can see the costs of certain assumptions, and you can, in terms of data structures, you can even calculate them in terms of the complexity of the calculations. and the big O algorithmic complexity of doing certain operations on certain kinds of representations. Range algebras are faster for some operations, and they are slower for others. And which of those operations counts more to you? If you say, oh, they all count equally, I love them all equally, your programmer is going to make his own decisions, or her own decisions. So you really, really want to you don't want to leave them alone. Now, the difference in use, in the telos of modeling, utilitarian on the one hand, and in itself on the other, is, I think, a difference that we have to live with, and we should be glad to live with. There's no need for us to say the purpose of modeling in digital humanities is one or the other. It should be both, I think. It should be both because theory and practice need to interpenetrate each other and need to inform each other. And if you don't worry about getting your utilitarian models correct, you're going to build systems that are not as useful. And if you don't worry about making your true models concrete enough to sustain implementation, then there is a sense in which you're not really able to put them to the test in the way that you can put things to the test when you can implement them. But there's another area in which we vary, where I'm going to be a little more prescriptive, and that's the form our models take. There's a whole range of, I don't want to prescribe a particular notation for models. But I do think that we do well to control our temptation to get by with informal models. Informal models it's too easy for them to provide an excuse for hand-waving. The more formal we can make our models, the easier it is to put them to the test, to see what their consequences are, and to force them to conclusions which may show us, by the absurdity of the conclusion, that the model has a flaw, and may help us therefore understand the thing being modeled better. So I want to argue that when we are taking modeling seriously as a way to make our assumptions and beliefs explicit, that it's better to be formal rather than informal. Now, sometimes bringing in the whole heavy machinery, wheeling in the engines of logical inference and so forth, seems like overkill, because really, we have pairs, we have named pairs, we have a name and a value, and do you really want to call that a data model? Various people have said, no, that's not a data model, that's too simple to be a data model. And I say to you, it embodies your assumptions, and if you don't identify them explicitly as assumptions, it will betray you. You have to be conscious of them. You have to surface them. So yes, by all means, call even as simple a thing as a set of attribute value pairs a data model, because it does embody your assumptions. There's no need to reserve the term data model for things that are big and complicated and intended to be permanent, any more than there is a need to restrict grammars to things that have 500 productions and can produce complicated English language-like sentences. Any grammatical system that cannot formally define the set of all strings consisting of any symbol in any order has a gap. And none of the serious grammatical formalisms has that gap. There is a reason that in conventional regex notation, the expression dot star counts as a regular expression. It's important to have that be part of the model of regular expressions. And similarly, we should not say, oh, that's too simple. That's not really a grammar. That's not really a regular expression. No, Even things as simple and unconstraining as that are regular expressions, and even things as simple as and unconstraining as, yeah, we got a bunch of attribute value pairs are data models, because they are embodiments of our assumptions. So what do we use? Well, my own instinct is to say the closer we are to first order predicate calculus, the better. Or some symbolic logic. And I say that for a particular reason. Chomsky says, the search for rigorous formulation has a much more serious motivation than mere concern for logical niceties or the desire to purify well-established methods of linguistic analysis. Although, frankly, I think those are perfectly good reasons. He wants formal models so that he can show what consequences they have and test them by their consequences. And if you don't have formal models, it's extremely difficult to test their consequences, because it's even, well, I'll come back to this in a moment. One reason to be formal in our models is that we want our models, or we should want our models, to be ways in which we can disagree with each other. Probably the biggest single indictment I saw of Ferber in Allen's incandescent indictment of Ferber's ontology is not really, I mean, yes, there were plenty of problems, but my biggest problem is I'm not entirely certain that after all his effort, Allen succeeded in disagreeing with those people. Because he said, oh, look, they say it has inheritance. It doesn't have inheritance. And I immediately said, are you guys talking about the same thing? And because they didn't formalize that part of it, I don't know. If you point to an error in the XPath data model, point to a logical problem, and report it to the working group, there is a risk that someone will say, oh, you know what we mean. And it's very difficult to sustain the task of saying, no, I don't. Or even if I do, there will be readers who don't. You really don't want to restrict a standard to the group of people who already know what it means. The whole point of externalizing information like a standard is to make it possible for people who don't know what it means a priori to learn and to interoperate. But formalization is hard, takes a long time, and working groups have other problems on their mind. A second reason to be formal is precisely that if something is formal enough, either in its original form or after we have formalized it, we can use logical inference to show what consequences the assumptions have. And we can test those consequences for their plausibility. And oddly enough, we can be surprised by that. This is a little surprising in itself, because as many philosophers have noted, Alan told me today, this is called the paradox of analysis. You know, when you have something that you're trying to explain and you say, all right, I'm going to explain this by providing another description, one of the most obvious constraints is, well, the meaning of the two things has to be the same. You have to preserve the meaning, right? But if you preserve the meaning, in what sense can you say that we've learned anything? We already knew exactly what you just said, because we said that other thing. This is a paradox, because in fact we do that all the time. I think this is just another instance of the limitation Alan pointed out. There are things that we don't know how to say very well in first order predicate calculus. We've been working as a species on formalizing our logic for hundreds of years, and there are still things we don't know how to do very well. There are things we don't know how to do at all well. So even while I say the most important new development for modeling in the digital humanities that I can think of, second only to the invention of the computer itself, is the development in recent years of better tools for model checking and satisfiability analysis, and the consequent development of tools like Alloy at MIT or various theorem provers, of which I'll happily give you a list and bend your ear later, that allow us to check the consequences of our assumptions in ways that were never possible before. We can write models that do not have glaring logical holes in them today because we can check them in ways that were not possible even 10 years ago. And if we're not using those tools, I want to know why not. If our models are at all complicated, it's worthwhile using those tools. It's worth using those tools in part because the devil is in the details. In the prospectus for the conference, the organizers say modeling is very important, it has fundamental implications, and yet in pedagogy and in the literature, it's always treated as a technical topic. And unspoken here, I hear the wish that we could treat it as a sort of non-technical topic. And I think that's not possible. It's necessary to treat it as more than a technical topic, but it is inescapably technical. Never trust someone talking to you about the intellectual implications of models and how assumptions have teeth if they've never built a model themselves. Just the way you would never hire a gardener who doesn't have dirt under their fingernails. So there are some technicalities that we really can't get by, can't afford to skip. Except I am going to skip. I was going to talk about well, there's one. I have a favorite complaint about RDF, but I'll spare you that one. But there is an interesting parallel between the intellectual move that several people have suggested, including Julia today, talking about the potential move from naming counties to always naming county time pairs, and atomizing things at preferably ever smaller and smaller units so they can be recombined. Well, as you can see, I've been experimenting with atomization myself. Recombination is not always easy, but you already knew that too. The thing that strikes me at first glance about that move is ultimately, if we do that consistently, we're committing ourselves to precisely the theory of atomic facts that is the least plausible part of section 1 of the Tractatus, right? No one reads section 1 of the Tractatus without saying, wait, every fact is atomic? What on earth are you talking about? I can't imagine a world in which facts are atomic. I mean, I can imagine that it would be nice for purposes of formal reasoning. I can see the rational, I can see the motive, the emotional motive. But as an account of the world we're trying to reason about, no. Unfortunately, I don't have any better solution. So as with many things, my only advice is do it and be really, really careful. Do it and don't get caught. Final note on the formality. There is one thing missing from many of our models, and that is, I think we would do better if we emulated our friends the linguists, as illustrated in Elke Teich's talk, in thinking harder about pulling predictions out of our models and making them testable. Max Schiech several times raised the issue of model assessment. And that's important for utilitarian models, but it's also important for models taken as ends in themselves. And we're not, as humanists, we typically don't have a lot of practice pushing conclusions out of premises. But that's a skill we need to learn to cultivate. There's a third cluster of issues that, that comes up in connection with modeling. And here too, there's a gap in the population here. I want to identify these issues around the axis of attitudes toward simplification and incompleteness. Several of us mentioned on the first day that one of the immediate reactions of scholars in the humanities fields to almost any data model you show them is, that's too simple. You're losing nuance, you're losing information, you're losing things. And this is a very serious reaction. It's a very serious sociological fact. It's also an important intellectual fact. One of the few things that is common to almost every attempt to define models is the observation that the model is almost always simpler than the thing being modeled. If it's not, oh, what was the point? Now, to a certain extent, that comes from the utilitarian approach, as illustrated by Wiener and Rosenbluth, right? We use a model instead of, because it's cheaper and faster. And we could use the original system if we can. Of course, if you're an astronomer, that's a little harder. If you're a cosmologist, experimental verification is just hard. But simplification is not only motivated by desire to save cost, either in time or in money. It can be motivated pedagogically. We build, models of the DNA atom to help students visualize what a double helix is, because if you just wave your hands like this, they don't understand the sides in your arms get twisted up. But when we treat models as ends in themselves, simplification is an important tool. It's part of the goal. And abstraction comes with that. And there's a lot of resistance to abstraction among traditional humanists as well. What Wiener says is, no substantial part of the universe is so simple that it can be grasped and controlled without abstraction. One reason that I know we're all geeks in this room is no one here was fighting desperately against the abstraction inherent in modeling. That we're all still in touch with non-geek humanists is visible in the many reports of people who bang on their doors and complain. But even hugely reductive models, like the delta distance that Fotis was showing earlier, can be enlightening. And in some ways, the more reductive the model is, the more astonishing it is that it should have that it should retain any information at all, and therefore the more useful it is. So although from the TEI and before onwards, many digital humanists have thought about modeling primarily in terms of preserving the nuances of the mess, we should also keep in mind that sometimes radical reduction is useful. And of course, those of us building resources for other people to use need to bear in mind that quite often what they're going to want to do is strip out much of the nuance. Steve Ramsey told me the other day, oh, I love the TI header. I love the TI header because it has a start tag and an end tag, and therefore the first thing I can do when I get a TI text is delete the damn thing. Because it's marked, I can delete it. I'm horrified, but that's why explicit markup marks things up so that they can be ignored. That's why some old HTML hands and XML hands react with a shrug when people say, oh, but I don't want all that interpretive stuff in there, because we say, well, turn it off in your browser then, for crying out loud. It's a switch. Learn how to use CSS, display none. It's not hard. It's really not hard. Just learn it. Do it. You got to build things. You got to be concrete. Incompleteness shows up in another way as well, of course, and that is that humanists often have incomplete data, and modeling incomplete information is hard. Modeling information we have is hard enough. Modeling the absence of information is even harder, and that's a place where first-order predicate calculus may be letting us down. But logic remains the best way we have for saying things in a formal way, for which we can see what the consequences are, and for which we can be responsible. Even though it doesn't handle non-discursive discourse and non-denotative statements, and it has problems with all sorts of illocutionary acts other than statement. It's now, what, 2012? So it's been 300, almost 300, no, 200 odd years since Leibniz imagined a language not terribly dissimilar to the languages that we have available to us today, in which you could formulate things and then check their consequences in the same reliable and mechanical way as you could use the calculus to calculate speeds and distances. And he imagined a world in which, when you had a serious disagreement with someone, you could formulate that disagreement in this language, and you could invite your interlocutor to the calculating machine and say, calculemos. Let's work it out. Now, a little while later, Leibniz's successor as librarian at the Herzog August Bibliothek, which I'm glad to see represented here today, Leibniz's successor, Lessing, described in his great play, Nathan the Wise, how some things that matter a lot to us, maybe we want not to put in the realm of things that we plan to decide mechanically and to correct each other on. Some things may be beyond the scope of calculatable inferences. And for those we must tolerate. We must cultivate tolerance. And then, a long time later, Kurt Gödel pointed out that even within the restricted realm of formal languages, there are things that it's possible to formulate sentences for which no mechanical proof within the framework of that system is possible. Now, it's interesting. Many people cite Gödel's theorem as a dark and ominous symbol, reminder of the limitations, the inadequacy of human endeavor. They always make me want to start singing Brecht. Der Mensch lebt durch den Kopf, der Kopf reicht ihm nicht aus. But that's not the way Gödel saw it. Gödel saw it as rescuing mathematics from the deadening influence of a purely mechanical proof theory. There are always things that are going to require human intervention and human ingenuity. It's the machines that are doomed to fail, not humans. Of course, some people think humans are doomed to fail too, but maybe that's not too bad. As Beckett is quoted as saying, ever tried, ever failed. No matter. Try again. Fail again. Feel better.
questions, let me just say, and I think Fotis probably joins me in this sentiment, what an incredible honor and privilege it's been to gather this group together here and to listen to everything that's been said and to have the opportunity now to digest it all and turn it into something that can continue to live and generate discussion and hopefully generate more work that we can do and more events that we can have. So thank you all very, very much. Safe travels.